Hello, everybody, and welcome to today's live webinar on AnyLogic 8.9, Git, Memory Profiler, and more. My name is Tyler Wolf-Adam, and I'm going to be your host and presenter today. Also helping me in the back end and for your various questions is my good colleague, Jeff Wirtz. Before we get started, I will first mention that the virtual AnyLogic conference is on September 5th. So if you want to register for that, you can go ahead and access that from the link there that's provided here. We have currently a great setup of various different presenters that we have going, and we're very excited to present those to you. So in terms of today's webinar, though, taking a look at our agenda, we're going to start with a 10 to 15-minute summary of the high-level overview of the features, and I've set this up in a way that it's catered to anybody, so regardless of your technical level. And after that, we'll go through a few demos of the major features, including ones on the new project format and the Git Perspective, the memory profiler, and the MoveTo API, and then the various different Java-related updates. Note that for the demos, due to the highly technical nature of this update, the assumption will be that you're already familiar with AnyLogic, at least at a beginner's level. And as always, this is being recorded and will be uploaded to YouTube with supplemental materials that includes everything that's being shown here. And then, as always, we'll have a Q&A section at the end, but I also suggest asking questions as I go, and Jeff and I will try to field those. So starting off, this update is intended for people to help your idea of tracking model progress and collaboration go from the mess that you see here at the screen to something that is vastly more efficient and useful. So with a kind of what I'll call a proper version control system, you can visually track your progress and have parallel work, see and write update messages, also see who made changes, when, and to what parts of your project. You can organize your work into different branches and later sync them up, add various tags, quickly compare and switch to different points of your project. And also it's much more efficient on your hard drive, as instead of kind of primitively duplicating the actual folder structure, version control systems like Git just track the changes over time, rather than having to duplicate maybe all the model assets that you've added. So for some context first about why this was not possible, or at least not easy before. So the original project format that many of you might be familiar with, which is the ALP file, that contained everything in the model, from the definition of your agent types to the usage of them, including the variables, space markups, and much, much more. All of this contained within a single file. Now, because of this, if you tried to use some kind of version control system like Git and looked into what files were changed in any of those updates, it will always report that single project file. So whether you're just moving a variable, a few pixels over, or implementing your entire flowchart and your custom agent types, from the perspective of your changes, they all kind of look the same. And so if you end up needing to track down changes from a specific area of your project, you essentially need to manually kind of go through and examine those changes. The various different messages help to provide some initial pointers, but it pretty much comes down to a lot of guesswork. This isn't a problem for traditional programming projects, as they are the source for them is split up into multiple folders and files. So the new project format fixes this by kind of literally splitting up the ALP file into its constituent parts, separating the definition of the types from their usage, and also separating out the space markup, variable typed objects, events, experiments, and much more. And so I just wanted to briefly break down how the structure is set up. And we will see an example of that shortly. So if you were to have a model that were to have all of the elements within that you could possibly have within a model, your new folder structure will look like this. So now instead of a single ALP format file, you have this ALPX file and this underscore ALP directory. This is then broken down into different subfolders and files. So we have different files for the experiments, model resources, folders and files for traditional Java classes. For each of your agents, they get their own folder, and that then gets broken down into agent-related properties, the objects inside of them, connectors, variables, and then again, as another level on top of that, you have your directories for the space markups, and then also a series of files that contain just the code-related objects. Now, I'll note that this is just the full structure. So if, for example, your project didn't have any Java classes in it, then you wouldn't have this classes folder and the class files, of course. And again, we'll be seeing an example of these in the demo section. So in conjunction with this, the new project format is the new Git Perspective. So the Git Perspective comes with its own set of views and features for almost anything that you want to do in a Git repository. So this includes being able to create, manage, and track any number of repositories, whether they're just local or pulling from a remote location, like a shared server or sites like GitHub or GitLab. And then other tasks like creating or merging your branches, seeing comparisons, detailed information, etc., is also possible. So now the result is when you look into any specific change, you could see exactly what was changed and what was added, if any new files were added. And you can then drill down further into each of one of these. So for example, in this delay block entry here, we could see the 4 files that were updated. This includes 2 updated files on main, and then 2 new files related to the functions. So presumably a custom function was added to the main agent. And again, you could drill down into this even further. And so if we look into the embedded objects file, we could see that the kind of default time distribution function was replaced with a custom function. And within this, this Git perspective, it also includes the ability to filter any repository by a specific file so that you can explore what was changed, when, and by whom. So in this example, we're looking at the changes over time specifically for the properties of the guard custom agent type. And we could see all those changes, and specifically that it was me who had changed the model, the scale from 10 to 1 meters. And so if this is causing some issue in the model, we know exactly who to blame for this. Moving right along, the next major feature is the memory profiler. So while your model is executing, you might find that it uses more memory that you might expect or intend, leading to slowdowns or crashes. And this can happen due to some unintended accumulation of data. So to allow people to explore this while your model is running, you can go into the view menu and go and take a memory dump. And so when you do this, you can drill into kind of how the memory is being used. And so this is a feature provided to the university and professional editions of AnyLogic. So for each dump, you're given an overview initially of the largest individual objects by their size, and then further actions that you could take, like seeing a tabular histogram of objects by their type, tree views to see dependencies, top consumers, and reports for leak suspects. And these are all provided as part of this feature. And we'll go into more technical detail in the demo section. Next, I want to run through some minor but very useful editor updates. So within the statistics of an agent population, we now renamed the reference from an individual agent from item to how it is in many other instances of AnyLogic, where it's now referred to as with the keyword agent. Additionally, we can now hover over variable to see their data type. And so this is very useful if you're either not familiar with the objects in a model and don't want to go digging around for, just to see the data type of it, or if you're, if it's one of your own models that you've forgotten about. Also is the ability when you are going to close AnyLogic or all of your models. Now, if you have unsaved changes for multiple models, you can select which ones that you want to save. Also, for those that do use traditional Java classes in your project, features such as control click to navigate or viewing a call hierarchy to see the calling order of a function or constructor class is available. Also, you can see an outline of the variables and functions inside of the Java class in a tree view similar to the projects view, but like I said, for Java classes. There are other features as well. These are just kind of some notable ones. And lastly is the overview for various technical and miscellaneous updates. So one is that the MoveTo block now has a new function for getting the distance traveled by an agent. This is functionality that is available in the material handling library that they've made now available for this process modeling library block. AnyLogic now uses Java 17, and with that comes a variety of new and interesting features, and kind of interesting, a lot more user-friendly features, such as multi-line text blocks, various different new string functions, and much more. And I'll be going over these with the demos shortly. We've also relaxed many of the PLE limitations, allowing a higher allowance for how long you could run models using industry-specific libraries. We've opened up the experiment framework and given the ability to import CAD files. Those of you with Mac devices with ARM chips can now utilize AnyLogic on that. And as with any common software update, we've squashed various bugs and updated some third-party libraries. So now to see it in action. So in my personal typical over-preparedness fashion, I have multiple, about like 7 practical examples to showcase the usage of all these features. But I'll provide the disclaimer that these are, like I said before, very technical in nature, and they're not meant as a comprehensive tutorial or as kind of learning material if you have no AnyLogic experience previously. I'm about to go through a lot, but keep in mind that the video, most of the models and more info will be provided later in the supplemental materials. So with that, I will go ahead and switch over to AnyLogic. If anybody has, as I'm going through this, feel free to ask questions in the Q&A section if you haven't already. Jeff, you are muted.
Sorry about that. We do have a few questions that were brought up during your profiler. So some of them that were brought up is if there's any differences flagged in Git, like comments as well, or any exceptions made, do any additions to that code get included in the Git changes as well and reflected in the differences shown?
If I'm understanding the question correctly, if you write any new code or comments and save the model, it's going to save to the respective sections of the source model. So that will be showcased there. I don't know. So if you write like code that results in some sort of errors, even if they're like syntax errors, that will also be included because it's just tracking the source code for the model. It's not like any traditional project. I don't know if that answered the question.
We did also have another one regarding the heap analyzer. Is the memory dump static, or are there any real-time or as the model is running capabilities of analyzing that heap?
Yep, I'll show that shortly, but it's a snapshot of when you take the dump. Yes.
And is this Git supported functionality available in any version of AnyLogic prior to 8.9?
No. No, so the new project format, everything that I was just explaining is all new to 8.9.
And I believe you will be, there's one other question about what are the prerequisites of utilizing a Git repository within AnyLogic?
I mean, technically none. If you know Git already, then so yeah, that going into my first model here, demo here, Git is a whole topic in of itself. And so for these demos, we'll only have time to scratch the surface. I suggest actually learning more about Git and proper usage of Git first, and then kind of coming into AnyLogic to use it there. Because again, it's like a whole thing of itself. Yes. So with that, I will go ahead and reshare my screen. This will let me. And let me just go ahead and about the chat. Okay, so starting off here inside of AnyLogic, you should be able to see AnyLogic here. Yeah, so starting off, I'm actually going to showcase a few different things in the new under tools and preferences. There's a new few settings added. So under the development, under the development tab, there's this checkbox for enable multi-part ALP beta. This needs to be checked first as a one-time thing in order to enable this feature. Additionally, under the advanced section, there are new categories for Git and SSH for settings related to those two things. So if you need to configure those are there. So with that, I will start off by going into our Git perspective. And what I will do, so the premise for this first demo is that we are a solo worker working on a project, and we're looking to build a simple queuing model. So I want to start off with just building a local Git repo. And again, for specifically this Git section, there's a lot of subjective ideas of what good practices are in terms of Git usage. So take everything what I'm about to say with a grain of salt. Similar to AnyLogic, there's multiple ways to go about doing various different things. And your organization might have its own specific ideas as well in terms of what you should be doing. So what I'll do to start is create a new local Git repository, and I will name it, webinar repo. So this repository will contain initially nothing in it except for this kind of Git folder. So now this is starting to track the changes within this this folder here. So now what I'll do is go back to the model editor section and create a new model. And I will save it inside of the webinar repo that I just created here. And I'll just name it my model. Now, the thing to note here is that because I enabled that setting in the properties, there's this checkbox here. And so enabling it will, you could see that it will now create this multi-part ALP format. You can actually notice that because this is a checkbox, whenever you're creating a new model or doing a save as, you have the ability to toggle back and forth between the two. So this is available. If you, for example, need to go back to the traditional project format here. And so I will go ahead and create this model and start by, if we actually go back to the Git perspective now and refresh the project, we can now see that my model is created. We have our ALPX file, and currently we only have the default experiment and one agent type with nothing in it, just main. So there's only a single file here. Again, going back, I'll start to create my flowchart and just a very standard source queue delay sync with some minor customizations here and there for this specific purpose. I'll go ahead and save this, switch back to Git. And again, now if I refresh this view, you can see that it just added those two objects or those two new files there. Now, whenever we want to kind of log our changes to the version control tracking, we need to what's known as commit those changes. So if I go to this Git staging tab, we can see that there are 5 pending files that are available to be recorded inside of this commit. And I'll go ahead and add all of them. And then I'll add some some random message, like create initial flowchart. Now, if I was working with a remote repository, like if I pulled this from a remote location, this commit and push will both log the changes and push it back up to the server. In this case, this is entirely local, so I'll just commit those changes. If we can then go back, kind of now the workflow is that, so kind of typically we work on doing a kind of a unit of stable changes. Again, this is very discretionary, and then we log those updates via a commit. So in this next kind of, it's a very iterative process is what I'm trying to say. What I'll do now is maybe create a new custom agent type for this flowchart that I'll later maybe populate with more info. And actually, let's go ahead and run the model. And we can see that it is indeed. And actually, let's actually go back and update the model time units to minutes. Let's save our project, go back. We could see the 4 files. The icons here have some meaning. You could see that because I had created that new agent, a new file was created, and then there are changes to the other files as well. And so I will, again, add some message like, see, we changed the time units, and create custom agent type. And we can go ahead and commit that. Now, if that probably should have been 2 separate commits. If I go to this history tab, so this history tab, similar to the properties, is dependent on whatever you have focused. So you can see that it's currently focused on main. So if we click our repo here, we could see here's our 2 different commits that we've made so far. If I wanted to undo just the commit itself, but not the actual changes to the file that I just did, what we could do is a softer or mixed reset. The difference between these is nuanced, but effectively it's just kind of undoing the, actually we need to go from the earlier point and reset to that point. So here we kind of undid the commit itself, but the structure is the same. And like I said, I want to separate this out into 2 separate commits. So so it looks like this main AOC file is one of the ones that changed the time units. And I believe also it's, this file as well that also was affected by that time unit change. So what I'll actually do is unstage these changes, create a commit just for these 2 files. So change units to minutes. And then I'll re-add these back in to create custom agent type. And again, to kind of double verify that, you can see that indeed this change is related to the new entity that was changed in the source block. And so now if we go back to our history, again, we could see that this is now 2 commits. And the other thing that I'll mention is that there's also a hard reset. This is will not only remove the commits, but also change the model, the file structures themselves. Typically you might have might get different opinions on whether you should use hard resets or when you should specifically, but that's something to keep in mind. Now with this ability to split this up into multiple files. One nice thing that you couldn't do very easily before was, let's say I actually didn't want to have the time units to minutes. I could revert this commit specifically, and because it's updating files that weren't otherwise changed, this is not grouped into one file, it is able to revert just those two files and without any need to worry about merge conflicts, which are kind of changes that occur when the same file has some overlapping edits to it, and you need to figure out which version of information that you want to save. Actually, kind of a hidden new feature is that when AnyLogic now detects changes to your model folder itself. And so when it detects those changes, it prompts you if you want to reload the model. So you don't have to kind of manually close the model and refresh it yourself. It does that automatically now with some prompting. And now if we go into the properties of the model, we can now see that it is indeed in seconds now. Now, typically, when you want to start doing kind of a convention in terms of Git is when you want to start doing more kind of intensive changes, or you want to do more robust testing in a separate environment, so to say. There is the notion of creating separate branches. And you could also have the freedom to go back to earlier points in your model and experiment from that point too. So for an example of that, I actually have another model that I'll open. This is a model that my colleague Jeff has been working on. And it's an epidemic model from the game World of Warcraft. And so if I go back to the Git repository and look at the history of it, we could see that. Let's click on actually, I opened up the model, but I didn't import it into the Git repo. So again, the Git repository works as a separate view from the model themselves. So let's go ahead and add an existing repo and go ahead and import this from my local model directory. And now I can go ahead and see that. So as you could tell from the history of this, this has been a model that he's been working on for quite a long time. And we can see all of the different updates, all the different files that were updated over time. And there's also different branches that have been set up to work on different parts of the project. For example, you could see that with my initials here. This is two of my branches where I am kind of doing two different things. So earlier, I had made some updates to the scale. I created that on a separate branch, later merged that in. I'm currently working on improving some practices in terms of the model editing itself. And this is on a separate branch from the main one. So if I was just testing something, I could freely experiment in this other branch and then delete the branch. Or if I want to later merge those changes, I can merge this back into the main branch as well. This also, in terms of branches, you could also go back and experiment with earlier points in the project. For example, if I want to go back to the point in the project 2 years ago, I can very easily check this out. And it looks like I have some uncommitted changes. So what I'll do is go ahead and stash those. Pre-webinar tests. So this will, what this did is the pending changes that I hadn't yet committed, it stashes them away so that I can later restore them when I come back to this branch. So I switched over to the earlier point in the model. It updated the local files and it prompted me to refresh the model. And I said yes. And so now we could start looking at how the model was 2 years ago very quickly. Again, if I had a reason that I wanted to go back and start working on something from this point, I could create a branch from this, just add some branch name that's however I wanted to. And so now I can do my tests from this point in the model, maybe if I want to go back and redo something over again. So that's kind of a high-level look at a few of the Git-related features. Now, the third thing that I want to show here is that, let's say you have a remote repository like GitHub, and you are more familiar with something like GitHub Desktop, which I can now actually pull up. So here inside of GitHub, I have this generic Ken manufacturing sim repo. And within this, I have 3 models. And so if I look into the file structure, you can see that I indeed have this Ken manufacturing library model. So this contains all of the source for the blocks and the agent types. And then I have 2 other models in this repository, which are intended as implementations of the library. So these are 2 different sites. And I want to now work on these models inside of AnyLogic. So if I go to GitHub Desktop, pull this up here, I can go ahead and clone the repository to my local environment. Alrighty, and then I will open this up in the Explorer so that I can then go to AnyLogic and now open up these models so I can start to work on them if I want. So again, the Git repository that we provide within the software has essentially most or almost all of the features that you would want to do for in a Git repository. But again, if you're more familiar with something like GitHub Desktop and you'd rather work inside of this workflow, that's also totally valid. So, and you can see that if I go inside one of the agent types and I make some change within it, move those over just to showcase that now when I go back, GitHub Desktop is now detecting those changes. And if I want to, I can commit those as well. I can also discard them to revert to the previous point. And AnyLogic detects that the source files were changed. And so now I can reload the model, see how it was before. Again, this also works if we have other branches here as well. So if I have, for example, adding a new feature for some new feature of the block that adds them to a population, I will go ahead and leave my changes there. So this applies not only to the single model, but because all 3 of those models has changes, I can now reload all 3 of those models. Ignore that. And so again, now if I want to continue implementing this feature, I can make some changes to one or all of these models, commit them, and then continue the kind of cycle again. And so for Matt, your question, how does the Git integration work with data files the model might read? So the Git integration, regardless of if you're using the Git Perspective or GitHub Desktop or anything else, even if you're just using the command line, the only thing they all track whatever is in the Git repository itself. So the folder with this Git. So if you add a new file inside of this local repository, then you have the option to track that file as well. If you reference something outside of this, like if I reference something in my desktop, for example, obviously those are outside the scope of the repository, so those just aren't tracked. But that more has to do with good practices in terms of version control systems than related to AnyLogic specific features. Okay, moving right along. So yes, in conclusion, in terms of the split format allows us to break down the model source into its components. So it allows us to see the changes over time easier with a version control system. And actually can actually go back to reemphasize that. So if I go into the the working tree, again, if I look into any of these models, we could see, or sorry, any of these files, for any of them that are being tracked within that repository, we can, within the history, because it's context dependent on what you've clicked, we could see exactly when these changes occurred, and look into more information about that. In case in point, this integrated Git perspective provides a built-in way to employ all sorts of useful version control features. And then there's also other features like auto-detecting changes, and this works regardless of whether you're using this Git perspective or any other software like GitHub Desktop. So with that, let's go ahead and move on to the next demo. I will not save changes. Close out of that. And we're going to go ahead and look at the memory profiler. And for this, we will use the epidemic model. So as far as I know, this is the standard built-in repository. I will just run the model once just so we could see exactly what's going on, where we have 10,000 agents, people that are created, and it models a contagious disease. And I'm not actually sure why this is taking so long to run. So yes, this infectious disease spreads in the population, and they go through the stages of being susceptible, exposed, infectious, and immune. And we could see over time how these different values, like the count of people, how it changes as the result of the dynamics that are happening. Actually, I'm going to pause that right there. If we open up the developer panel, we can actually see that it's taking up about 80% of our ½ gig of memory, which is very strange. So to explore that, let's keep the model paused in the background. Let's go ahead and actually it's under the model tab. Go ahead and take a memory dump. So again, like I was saying before, this takes a snapshot of the model in its current state and creates a dump from this. There's no reason why you can't take multiple ones as well. And actually one of the features that I won't be showing here, but are also available is the ability to compare multiple snapshots. So what I mean is that I can let this run till the end, for example, and then go back and then take another memory dump. And this should open up shortly. So once these open up, just to make sure that nothing goes wrong, I can now safely close the model because it's captured all of that information. Let's go ahead and close that. So again, 2 different memory dumps. You could take in any number of them as your model is running. And again, there's built-in features to compare the results in each one. But again, it looks like these are mostly about the same. We'll just use the first one. So yes, with that, we're first brought to this overview screen where we're showed some high-level details like the specific amount of RAM, the classes that are used, the objects, and the biggest individual objects by their size. In this case, it looks like the biggest individual object is rather small, and it's actually related to a backend part of the engine, part of the executable that's actually running the model. So that's kind of not really useful information. To start off with, we can start by doing checking this leak suspects. And this looks through the memory usage of all of the objects and kind of tries to figure out, give you some suspects for where these and any memory leaks might be occurring at. And we could see that it points out epidemic.person. So for context, if I just to point this out, if I go to my model properties, we could see that epidemic is the name of the package, person is our data type. And it looks like it's occupying almost 97% of the bytes in the RAM. So this is strange. So next up for kind of, I got another high-level look. We could check out the top consumers to print out the most expensive objects. And it's grouped by type and by package. And again, this also shows that it's the person type that's not only a leak suspect, but also it's also the biggest object by grouped class. There are some other charts here as well, but they kind of go into like the class loaders that get into a level of technical detail that for this example, at least, is not pertinent. Let's go back. And so to get some general information, let's check out the histogram. So this says per data type, how many objects, instances of that object are there in the entire executable. And then it gives the shallow and retained heap. So as you can see, this lists literally all of the classes that are used inside of the executable. And there are ways to filter or group this that I'll show shortly, but I just want to explain that shallow heap is essentially the amount of memory that's taken up by just the type itself, not any of the objects inside of it. So for some things like a double array, because it's dealing with primitives, it will be the same value as the retained heap, which is telling us the size of the object itself, so the shallow heap, plus the size of all the objects inside of it, which is essentially what we care about. So something like an array list itself is taking up a little over 5 million bytes. Just the array list object, not the instantiated objects that are in that array list. But when you include that, it is over 100. For our purposes, we mostly just care about the retained heap. Now, initially, it just shows an estimated value. So it's estimated to be this amount. We could use this calculator to calculate the precise size. And because this might take a while, because there's a lot of objects in this model, I'll just kind of prematurely cancel this, but we can get more information here. And because this is a table, we could do things like sort by any of the columns, and we could also use some regular expression syntax to search. So if I do person, it will look up, or actually I guess kind of even better would be epidemic, which is the name of our package. This will filter by everything that matches this query. And so we could see all of the classes that are part of the epidemic package. And if we sort this by retained heap, we can indeed see that the person type takes up most of that. Now for these other kind of $ value, these are inner classes that are built based on the objects that you add to that type or some properties that you set. For the most part, you can disregard these because for the most part, as you can see, they take up kind of a negligible amount of space. Again, these numbers, the heap-related numbers are in bytes. As a rough calculation, you can kind of move the decimal point over 6 values to get the kind of a very, very rough approximation for the megabytes, for example. So yes, so this is kind of, so we know, again, from all of these, we know there's something with the person type. Let's kind of drill into more information by looking at the dominator tree. The dominator tree will show us for each of the types, what are, for example, the person, what are the objects that are contained within that, or if we removed that person instance would get garbage collected or removed from the RAM. And again, in this view, it kind of shows us everything here. If we want to, again, we could search by person. And as you can see, this breaks down the type into the individual, in this case, the 10,000 instances. So we could look at for each person, what are the objects is keeping it alive. And now we kind of only care about this at a kind of a high level. So what we could do is utilize this grouping feature to group by the class. And this warning is telling us it will clear out our query, which is fine. And so now we can drill down into the person and see for their 400 million bytes, the largest section of that is this time color chart type, which is taking up the vast majority of that. And that's weird, I guess. So if we go back to the person type, we can indeed see that this built-in example was modified by me previously, spoilers, to add this time color chart, which every day is tracking their current state. And it's keeping track of 730 values. So this times the 10,000 people is why this is taking up so much size. So if we wanted to reduce this, like if the current amount of usage was too much, we now have a pretty clear target to question whether or not we need this time color chart at all, whether we need this detailed information, or if we maybe should reduce it to some smaller value to keep track of less information per person. Or maybe we only track 30 days and then have a separate event that kind of logs all of that information to a file and then clears out all of those data sets. Again, this is just if we want to reduce the RAM usage, so we could start to drill into what's really necessary. Also, if in terms of like if we were tracking too much data and we got a heap exception, out of memory exception, we have a pretty clear idea of how we could solve this, including just increasing the RAM maximum available memory too. So again, that's just a high-level look at the memory profiler. And we can close out of that. One thing to note is that when you do close out of those snapshots, they are effectively destroyed. If you want to save those, there are features built into that as well. And again, I'll provide some more links and information that kind of details all the features as well. So yes, let's go ahead and take a look at some of the other ones. I believe I have. Okay, so this is kind of a lighter example. We're getting into some of the more alternative update-related settings. So here we have one of a modified version of a built-in repo. This is looking at two different types. We have a car and a train type, and they both start out at Paris, and they're told to move to Nice down here. Now, the thing is that we want the routes that they take to be of two separate routing types. So we have the default GIS map set as the car type. And for the train, we wanted to use the rail type. So we've added this train provider, the route provider object, and this can then be referenced by the populations. So this car's population uses the default routing, whereas the train's population uses the routing population. Each type, when they're created in the source blocks for each, are added to their respective population, and then they're both told to move to Nice. What we have here is an example of the get distance traveled function. So whenever they exit this block, we create a new local variable called distance, which calls the get distance traveled function for the move to block itself, passing in the agent, and we want it in kilometers. And then we print out using traceln and specifically the formatting variant, agent blank. So this %s tells it to parse the value as a string, traveled blank kilometers, and then we pass in those two respective values here. And if we run the model now, we can verify that both they use different routes and indeed they do. And if we look at the console, we could see that the agent train traveled 940 in some kilometers, whereas the car traveled 930 in some kilometers. If we wanted to do something else with this data, we could, modify the, little snippet of code here. The only thing I'll mention, the only other thing that I'll mention here is that unlike other blocks, this information is only saved as long as the agent is in the block still. So if we were to call this get distance traveled and passing the agent, for example, in the sync block, it would throw a model error because once they exit this block, that information is lost. So if you want to save that somewhere, you should do that in this onExit field. Okay, that was that example. Let's move right along to the next one. Now we're going to look at a few related to the Java-related updates. These are some of my personal favorites. Okay, so here we have a model depicting a support ticket servicing system. So people come in, submit support tickets, and these support tickets can be from either normal or high priority, and they could be either related to sales, technical questions, or business inquiries. We have 2 resource pools to answer these questions. And for example, for the representatives, they are loaded from their parameters are loaded in from the database, and they have a sales skill and a technical skill. For example, the first representative that gets created will have 0 sales skills, so they should never be used for any sales-related inquiries, and they are fairly proficient with their technical skills. In contrast, the third one created is very high in their sales skills, but they should not be on any technical tickets. And then we have 3 that are kind of have some mixture in the middle of both skills. For this model, the other thing is that, so they come in and based on their request type, they get filtered to either the 3 respective service blocks, which all have different requirements in terms of the resources that they use. After helping, they then wait for a response, and if they need to follow up, the last representative that they were in contact with gets used for any follow-ups, and then they kind of loop through this, and once they're done, it gets closed. For the question, will the database tables be tracked by Git as well? Yes. Yes, they will be. Because the database is just a folder in the model repo. Yes, so with that, yeah, we can go ahead and so yeah, the first question is, actually, let me just go ahead and run this first, just so we can see what this looks like. So we could see that these tickets are coming in, the kind of lines are who they're being helped with, and the representatives have their skill levels both here as a multi-lined text object. So we could see how this runs over time. We also have one manager who's helping out with business requests. Now, the first thing to consider is the how we're implementing the selection or the sorting of the request type. So what we could do, so there are 3 different outcomes. So what you might start to do is use a ternary operator. So we could have a condition and then a value of true and then a value of false. So this could be based like, are they sales requests? Then they should go to the exit number 1. But actually, because there's 2 other options, we would actually need to kind of nest this for the false case and put this in parentheses. This is actually kind of an unclean way to do it in this scenario. The other way that you see here is that we can call a custom function and pass in our agent as input. So what you might do is pass in that agent and use an if-else-if statement. So if they're normal or high sales, they go to exit 1 for the sales requests service block. For tech, they go to exit 2, business number 3. Totally fine way to do this. If this is what's most natural to you, this is the way that you should go about doing this. If you wanted to squeeze out some efficiency, and as an alternative, you could use a switch statement. So a switch statement, we switch over the type, and then we have multiple cases that have the same outcome, which is so for normal or high sales, we set our exit number to 1, and then we break out of this switch statement. And then we need that for all 3. This is also completely valid, but it is kind of it's kind of a visual improvement, I guess, from the if statement. But wouldn't it be great if there was an even cleaner way to do it? And one of the updates in Java 14 specifically was that there's a new switch statement, which allows us to do 2 things. One is that we can now assign it directly to a value rather than needing to, if I go back to the other one, assign some predefined variable in the code block. We could also use a comma separated list and also use an arrow symbol so that it will, for sales, it will set it as 1. And actually, we could simplify this by removing this kind of redundant here with the exit number. And we could actually just have that. So that would be totally valid. And actually, because of the fact that we're just returning the statement, because this is now able to be condensed to a single expression, what we could actually do instead is put this directly inside of the exit number. So if you, for example, this logic is only being used in this block. If we didn't want to deal with having a separate function for this, it's kind of much more streamlined and like visually apparent that you can click on this block and immediately see, okay, this is how the exit number is formulated. So this is very convenient. The other thing is that one other Java-related feature, spoilers, if we look into the business requests, you can see that it takes in 1 manager and 1 representative. Now, whenever you have some sort of callback that references a object that could be of multiple types, it gets casted or converted to the highest shared equivalent. So because there's both a manager type and a representative type being used, AnyLogic passes the unit as an agent type. And if you want for any reason to access the values, the attributes inside of one of those types, you need to first check the data type of it. And if it is that data type, you would traditionally need to typecast it and then access the value. In this update, as of, I believe, Java 16, and if I actually show the support ticket itself. So again, whenever the support ticket sees a resources, we want to connect it to the representatives link if that unit is an instance of representative. So traditionally, we would need to check this instance of. If it is, we declare a new local variable for the typecasting, and then we can now connect it to this representative link, because this link is expecting a representative type specifically, not just a generic agent, which actually we can, as I'm showing, can now see based on its inner data type. So in this update, what is provided is the ability to instead declare a local variable inside of that instance of. And so now if that unit isn't indeed an instance of the representative type, Java behind the scenes will create this local variable for you, and now you can access it directly. So no need to typecast. This is also true in our business request, for example, where we want to, or wherever we want to check the sales skill if it's a representative. So again, traditionally we need to instance of representative. If it is, typecast, and then we check if it's greater than 0. And if it's not a representative, if it's a manager, then it'd be false. Again, we can now do this by declaring a local variable, and now don't need typecasting. There's 2 other quick examples that I want to show. I know we're kind of running up on the hour. This is being recorded, I'll mention, and will be provided in a update email, and then also uploaded to YouTube as well. So the models and the recording will be available. So yes, in this model, the last thing I want to show is for the representative, we have a multi-line text object that we want to update on startup with the actual skills of this representative. Additionally, you might do something like this. So the label equals sales skill plus new line plus text skill. And if you want to, round the value, you might have to then do round to decimal, sales skill, comma 2 again, and so on and so forth. Again, this is kind of clunky and annoying. What you might choose to do instead, again, traditionally, is use the string class type itself as a function called format that we can do, %.f. So this is, instead of %s for string, this is a floating point that we want to truncate to 2 decimal places. Again, new line symbol that you kind of have to know in advance. And then we could pass in sales skill, text skill. Again, totally fine way to do this. But there's actually, as of Java 15, now a way to do multi-line text blocks. So we could do a triple quotation mark. It has to be those double quotes. And then we could do %.2f, %.2f. And now strings themselves have a formatted function, along with a variety of other new functions as well. So we could do sales skill, text skill. And so now we could have kind of a cleaner way to, you don't have to remember the \n. It's kind of a more visually apparent way to look at this, to visually see what's going on. So that is that bit of the examples. 2 other quick things. So in terms of do I have this up? Yes. Again, on a similar note, we have the modified version of the activity-based costing analysis model. Again, the new string functions could also be helpful in a variety of other situations. Like for this optimization experiment, we are minimizing some metric based on 4 different parameters. We might want to print out after each simulation run the set of inputs that were used and the output. And again, traditionally, what you might do is the value plus tab plus value plus tab plus value. This is crazy. Very annoying to do. So again, there's another variant of the trace_len function, which allows you, like I was saying before, to do these placeholders. So you could do placeholder, tab, placeholder, and you could just copy paste this. And then if you need to add, another value, you could just do tab s and then put in that, other value here. Both of these are technically totally fine. I have run into situations personally, though, where I, miscount the number of, %s tabs that I do, and then that sometimes causes an error or doesn't print out the information that I want. It's kind of annoying. One of the newer functions for strings is a repeat function. So now we could just do %s tab dot repeat, and I can see that there are 5 values, so I'll pass in 5 here. And again, now if I want to add a 6th value, I could just, put a 6 there and now add my 6th value. So minor thing, but very useful. That is that. And one other quick example model before we get to Q&A is I want hierarchy test. So this is a model where we have a series of households and a series of randomly created jobs from a variety of different industries. Each household has a population of people, a random number of them. And on startup, the people get assigned randomly jobs, and some of them actually don't get assigned jobs. And we have this function called getHighestEarner, which filters the population of people by those with jobs, and then it returns the top person based on their income. And to clarify this again, we can go to person agent and see that they have an income, which when they join a job gets assigned some income. Now, when we click on the person animation, what we want to have happen is it gets their household and then gets their highest earner. And for the highest earner of their household, it gets their job and outputs their industry. And I assign each industry kind of a random color. So if I click on this person, see blue is for tech because they're the only one here. Click on this person, the highest earner is in retail. In this household, it's manufacturing. And in this household, well, I get a null pointer exception because of something. Now, before the Java 15, what you would receive is a null pointer exception with some reference to the Java code field that highlights the entire line. So now it's your responsibility to either use the debugger or to figure out which part of this is null, because this is a kind of a chain statement, or you have to go through and break this down into variables, check if it's null, check if it's not null, add a bunch of code to figure out where in this chain the null is actually occurring. And actually, in more complicated cases, very often it could come from one source, but not the other source. It's very annoying. So again, in Java 15, what they added was a very helpful message that says it cannot invoke hierarchy test.person.getJob. So this is our package type. This is that getJob function. So it can't call or invoke getJob because the return value of getHighestEarner is null. So we know specifically from this message that it's getHighestEarner that's returning null. And so now we can, properly handle that. And we know exactly what to do now. We don't need to, go through any steps. We know this value is null, and then have a error-free model. So again, that was just a recap of kind of some examples of the various different Java sections and the assortment of other updates. With that, I will go ahead and field any questions that might have been unanswered.
So something that was a general theme of a lot of questions, Tyler, is how Git integrates with databases that are integrated into the model, whether it be the internal AnyLogic databases to other examples such as just external ones as well. How does Git work with and incorporate specifically the ability to track or ability to not track changes in databases?
So it works the exact same way that it works outside of AnyLogic, which is all that Git is doing is tracking how files are changed. I'll actually go ahead and reshare my screen. So if we go ahead and look at this support model that has a database folder in it, when you open up a database, it has some lock files and log files that are just there too. So let's actually close this. So because this is not linked to any external databases, it's manually created. Everything is defined in this script folder. And let me actually open this with something else. Okay, here we go. Let me pull this over. So it has some, SQL-like code that, generates the values. And actually, this is, I believe, yeah. So if I were to change, for example, if I were to add a new row, the change that you would see would likely be that, a new value gets put here with the values that I add here as well. So yeah, there's also a properties folder or file which has some, internal information on the last time it was modified or updated. Again, let me go ahead and open this. So again, we can see the properties of this. So whenever you open up the model, this file is going to get updated. If you didn't want to track these changes, I'm actually not aware offhand if there's any implications, if this is, how this might, not tracking this might change it. But there is, whenever you're within things like Git, there is the ability to ignore files that might have changed. So if you want, for example, let's see if I go to this, if I wanted to, for example, ignore any updates to the lock file, I could choose to ignore this. And so now it actually adds to, it creates what's known as a git ignore file. And so in this file contains all of the types or files that are being ignored or untracked by Git. Now, is it a problem if we don't track the lock files? I will actually need to check on that information. But if you want to, there is a way to ignore certain file types. But this is kind of a general overview of how it works. If it's remote databases, obviously that information is not going to be tracked unless it's contained within the working tree of the project, which it's remote, so it's obviously not. But this is true for any sort of software that's tracking, project changes with something like Git. Other questions? Oh, yes, there is a the minimum Java version to run models. Now you need Java 17 or above. Any other questions? Once, twice. As we're finishing up, I will just also recap that the AnyLogic conference is coming up in a little under a month now. So again, if you are interested in joining that virtually, that is available. All right, then. Is the real...
I was just going to say also just a reminder, everybody, this webinar and all the supplemental materials will be made available shortly once we have published the recording of the webinar, which should be within a day or two, I believe.
There was one other question. Is the railcar example included in the files being available to us? Yeah, any models that were added to the repository that were shown in the change logs are available. I did not have a railcar example, but yes, any of the new built-in example models can be accessed from inside the software. All right, well, thank you all again for joining, and have a good rest of your days. And with that, we will bid you all adieu. Thank you for joining. And for the anonymous person, yes, you can track the database. Alrighty, have a good one, everybody.